last year. And so at this point, I hear the music. I'm going to give it to you, Valérie.
Thank you very much. So I have the first one is to give you an overview of 3 IPCC reports in a short amount of time. And the second one is to be able to speak despite having COVID during this presentation. So I'm doing my best. So we are now at 1.1 degree of global warming, and the amount of global warming to be expected depends on our greenhouse gas emissions, how we influence the global climate. It also depends on the response of the climate system, if it's in the upper range of what we know, and it is illustrated here through the well-known climate stripes. So let's dig into this a bit further. So IPCC reports, it's the work of hundreds of scientists who look at the evidence available in the scientific literature, and then they digest the key findings expressed with a degree of confidence so that the assessment is rigorous and transparent. And the reports are reviewed broadly by the scientific community and experts nominated by governments. So at the end, the summary for policymakers, which are approved by delegates from all governments, they constitute a body of scientific knowledge recognized by all governments. The first thing I would like to stress is how human influence on climate is now unequivocal. And when you look at human influence on climate, the first thing to look at is how we alter the global planetary energy budget. We do that by increasing the concentration of greenhouse gases in the atmosphere. And just by looking at the last 30 years, you can see that our emissions are reaching the highest levels in human history. What matters most are carbon dioxide emissions when we burn fossil fuels and from the industry, and methane emissions from fossil fuels and from aspects of agricultural activities, such as livestock. There's a positive sign, the slowdown in the growth rate of our emissions of carbon dioxide. There are huge inequalities in how we affect the global climate. Some emissions per person are much higher in some regions of the world. It's the case in North America, Australia, Japan, or Europe. And if you look at families, the 10% wealthiest households account for around 40% of emissions of greenhouse gases, while half of the world's population counts for less of 15% of emissions. And if they would have access to basic energy services, it would have almost no impact. So it's really a matter of lifestyles and consumptions. And this is also reflected by an increasing share of greenhouse gas emissions from urban areas. There's increased evidence of climate action. Some countries have already reached a peak and a steady decline in their greenhouse gas emissions, even accounting for trade. Cities and regions have ambitious emission targets. And the costs for low carbon electricity from renewables, the cost of batteries have fallen, allowing to reduce emissions from cars. Capacities installed have increased. Let's now go back to the climate system. So through our emissions of greenhouse gases, we are altering the atmospheric composition. And if you look at the CO2 concentration in the atmosphere, it's now reaching a level unprecedented in several millions of years. We are altering the global water cycle with an intensification of the water cycle. Glaciers are losing mass at a rate that is unprecedented in more than 2,000 years. The rate of sea level, which results from ocean warming, taking up more than 90% of the excess heat that doesn't go to space because we've added greenhouse gases. So the ocean is heating and expanding. Glaciers are melting. This adds to the global sea level rise, and the rate of sea level rise is accelerating. It's at a pace that is unprecedented in more than 3,000 years. So we're seeing rapid and widespread changes in each component of the climate system. A key indicator is the level of global surface warming. It is here reflected compared to the average value at the late 19th century. So in the last decade, that indicator is reaching 1.1 degree of warming. It's unusual, as you can see, in more than 2,000 years. In fact, if you want to find a period warmer than that, averaged over centuries, because that's the information we have from past climate archives, you need to go back to the previous interglacial period, more than 100,000 years ago. What's playing the key role for the warming that is observed? This is the result of attribution studies, and there have been major advances. I would like to flag that when we compare observed warming to what is the result of human influence, our best estimate is the integrality of the observed warming is the result of human activities. Of course, natural climate variability plays a role from a year to the next. Sometimes at the decadal scale, even more importantly at regional scales. The climate reacts to variability in the sun, variability in volcanic eruptions, but this does not cause an accumulation of heat. That accumulation of heat is the result of our emissions of greenhouse gases, and their warming effect is partly counterbalanced by the cooling effect of pollution particles that we also emit when we burn fossil fuels. We have also a better understanding of what plays a major dominant role, and the first one is carbon dioxide. The second one is methane. Methane has a direct warming effect. It also affects air quality. It leads to ozone and ozone pollution. Ozone is also a greenhouse gas, so there's a double effect of methane emissions, and it makes it the second most important component to warming to date. So altogether, human influence on climate is now unequivocal. It's an established fact, and it's the case for air warming near the surface, for permafrost thaw, Arctic sea ice retreat, glacier melt, or the growing length for vegetation, the season of growing for the vegetation. It's also the case for ocean warming and ocean acidification, as well as sea level rise. Just one point, the amount of melt from the Greenland ice sheet and the amount of increased flow from the Antarctic ice sheet has been multiplied by 4 since the 1990s, and that, together with glacier melt and ocean warming, explains the observed acceleration of sea level rise. Just thinking of global warming, you can see that the pattern is not exactly homogeneous. Warming is larger over land, and it's much larger in the Arctic. But when did people experience novel climate conditions? When did that warming trend emerge from the background variability? Because temperature is more stable from one year to the next in the tropics and more variable near the poles. In fact, the human-driven trend of warming has emerged earlier in the tropics, sometimes before the 1980s, then at our temperate latitudes, mostly in the 1990s, and it has emerged also in the past decades in the Arctic, for instance. A novel finding is that human activities are also intensifying extreme climate events, especially heat waves, heavy rainfall, and in some regions, droughts. It is illustrated here. Each hexagon is a world region. Each red hexagon is where we observe an intensification of hot extremes, more severe, more frequent. And the more you see dots, the more confident we are in the human influence on this intensification. And you can see it widespread for hot extremes. For heavy rainfall events, it's also the case in many regions, but we lack available data and studies in many countries in the global south. Where the signal of human influence is strongest is in Northern Europe. And when we look at agricultural or soil moisture droughts, you see that there's an increase in these droughts in places with a Mediterranean-type climate, such as California, the Mediterranean area, but also Western Europe or South Africa. And why does it happen? A warmer atmosphere increases evaporation and transpiration, and in some regions it adds to a tendency for precipitation decline. For heavy rainfall, it happens because a warmer atmosphere can hold 7% more moisture per degree of warming. So there's a basic understanding of the processes of what is observed, simulated, and attributed to human influence. Every region is affected in multiple ways. In cities, hot extremes are amplified, especially at night, by the urban heat island effect, as we have seen around Paris in the last week. There are also increased conditions associated with what we call compound events, hot and dry conditions that lead to fire weather characteristics, or at the same time, during a storm, an increase in extreme sea level, because it adds to the sea level increase, and an increase in heavy rainfall overland, with a double challenge of protecting from salt water and evacuating rainfall or river water to the sea. The ocean ecosystems are facing multiple threats: increased heat waves, acidification, loss of oxygen, and sea level rise affecting coastal ecosystems as well. When we talk about climate-related risks, it's the overlap between hazards related to the level of global warming and regional implications, trends, extremes, events, with vulnerabilities of ecosystems and societies. And now there are more than 3 billion people in high vulnerability context. They have climate-sensitive livelihoods, they face water scarcity, food insecurity, they lack basic infrastructures, and their infrastructures are vulnerable because not designed to be adaptive to a changing climate. And by 2050, 1 billion people will be directly exposed to sea level related hazards on the coast. But we can also reduce risks by taking action. Adaptation is available if we avoid maladaptation that can increase future exposure or future vulnerability. We can also reduce pressure on land so that we reduce the threats on ecosystems and can better benefit from their services. So let's dive deeper into that. What we already see is that global warming has caused dangerous and widespread disruption in nature. Changes in ecosystem structures, changes in species range shifts, and changes in the phenology and timing of the first flowers, the first leaves, the migration of birds, and other aspects of nature. Altogether, half of the assessed species over land and in the ocean are shifting towards the poles or towards higher elevations to just keep with their preferred habitats. But we also create many pressures by unsustainable use of natural resources, fragmentation of habitats, damages by pollutants. And these multiple threats will, can undermine the ability of ecosystems to adapt. Two illustrations here: increased tree mortality and forest deperitions that are observed, and increased warm water coral degradation as a result of more frequent and more extreme heat stress. Regarding societies, we also see widespread impacts despite efforts to adapt everywhere. Impacts on health, for instance, from increased heat events. Impacts on crops by heat and water stress or flooding. Impacts on infrastructures, for instance, damages resulting from fire events or from floodings. We also see that risks due to extreme events are increasingly complex and difficult to manage. For instance, a prolonged period of extreme heat and drought can reduce the ability to work for farm workers. It means their livelihoods are reduced, while due to the shocks on agricultural production, reduced crop yields increase food prices. And this has local effects on food insecurity, health, and the life of billions of people. Where are we going? We're not on the good track unless there are immediate and deep reductions in greenhouse gas emissions in all sectors. Limiting warming close to 1.5 degrees Celsius and well below 2 degrees the targets of the Paris Agreement will be soon beyond reach. To explore future climate, we use socioeconomic pathways associated with the description of how human influence will affect the climate. These are 5 examples of such illustrative pathways. One is following a sort of current policy pattern with a slow increase of global greenhouse gas emissions and then a slow decrease. Other scenarios imply higher use of fossil fuels and even higher emissions. These ones are considered now less plausible because of climate policies in place and because of affordable clean energy, thanks to advances in costs. And we also look at lower or very lower emissions than implied by current policies, where global CO2 emissions reach 0 by 2050 or by 2070. That's really important because a key condition to limit warming, we'll see that later, is to reach net zero CO2 emissions. And when this is reached, there's no more CO2-driven warming in the pipeline. So when we look at these scenarios, we can see obviously that future warming will depend on future emissions. In the near term, the next 20 years, averaged over 20 years, will reach a level of global warming of 1.5 degrees Celsius. It means that by 2030, there will be a likelihood of about 50% to be above that level for every year. By 2050, we could reach, surpass, or avoid reaching a level of global warming of 2 degrees. But this depends on our ability to decrease fast greenhouse gas emissions. And with current policies, if there's no more action, then we could reach a level of warming of between 2 and 3.5 degrees Celsius by the end of this century. Higher levels of warming are a lower probability if the response of climate is in the higher range, or if we lose more efficiency of carbon sinks than we currently take into account. So every further increment of global warming amplifies changes in every region, and you can see how much the amount of warming in each region amplifies with the amount of global warming. Regarding the water cycle, it intensifies with warming, with cold regions having more average precipitation, regions of Mediterranean climate having, in average, less precipitation. In very dry areas like the Sahara, you can see that there's a small increase of precipitation that is compared to very limited amount today. That's why it appears as a green pattern. When we look at soil moisture in average over the year, because of increased evaporation and transpiration, and in some regions a decrease in precipitation, many regions actually get drier. It's the case in the central US or the Amazon region, South Africa, areas in Asia, around the Mediterranean Sea. And that pattern of decreased soil moisture gets larger and larger with a higher amount of warming. So that's why the level of global warming matters, because many changes directly scale to that. It's also the case for the increase in frequency and intensity of hot extremes, heavy rainfall events, drought in the drying regions, compound events, the proportion of most intense tropical cyclones, categories 3-5, the retreat of the Arctic sea ice, the thaw of frozen soils, the loss of spring snow cover. And for instance, if you look at a heat wave that had a probability to happen only once in 50 years in pre-industrial climate, it's already 5 times more likely to occur. And that likelihood doubles for a level of warming of 1.5 degrees Celsius. And it increases again further with every increment of global warming. And peak warming for such extremes increases more than the global average as well. For some aspects, there's no going back. Glaciers will take decades to adjust to current climate. For the deep ocean, it's hundreds of years. It's also hundreds to thousands of years for ice sheets. And as a result, sea level rise will continue during thousands of years, with rates and magnitudes depending on future emissions. By 2050, our uncertainty is really limited. By 2100, the amount and rate of sea level rise will depend on emissions, and we can avoid a further acceleration of sea level rise with low or very low emissions. We also report a storyline in the case of ice sheet instability from processes currently associated with deep uncertainty. And you can see that with very high emissions, we cannot rule out a sea level rise that could reach 1.5 meters more by the end of this century. And that's the type of information managers of critical infrastructure, coastal cities, harbors, are requesting to have so that they can prepare for the tails of risks, not just the risk associated with the highest confidence. For sea level rise, it's again a race against the clock. There are options to act that can be implemented quickly, restoring coastal ecosystems, moving sediments. But the margin of adaptation provided is limited, and these options cannot work beyond 2050 or for high rates of sea level rise. Other options take time to design, fund, implement. And the only options that can really avoid coastal risks is not building on the coast or planned relocation. All the other options, they postpone risks. With a peak warming of 2 degrees by 2000 years, we are committed to 2 to 6 meters of sea level rise. For 3 degrees of peak warming over 2000 years, it's 4 to 10 meters. So climate change, it's already affecting every region on Earth in multiple ways, and people react. What matters is to look forward and to take into account how the change we already experience will increase with further warming, so that we prepared and we not just have reactive adaptation, but more transformative adaptation to be ready and limit risks associated with continued changes. If you want to look for more information, you will find in the Working Group 1 report information at regional scale for 33 climatic characteristics, trends, and extremes that are known to drive impact today. And for most regions of the world, if we reach 2 degrees by 2050, there would be 10 or 15 factors changing at the same time in every region. That information is available in the IPCC Interactive Atlas. You can navigate across regions and have access to that information, what changes are observed, attributed, and anticipated to increase, or directly climate variables that matter for you. You can also have fact sheets that are regional 2-page summaries for every region. The main message is that climate risks will depend first on the level of global warming. It's the case for dangerous heat, number of days associated with hot and moist conditions that are dangerous for human health. It's also the case for changes in extreme rainfalls in the tropics and in the high latitudes, so that you can see that all regions are concerned with an intensification of these hazards as a function of the level of global warming. But climate risks also depend on the state of ecosystems, and every further increment of global warming will increase the severity of impacts for terrestrial and marine biodiversity. As a function of the level of global warming, the risks of biodiversity loss will increase. For hotspots of biodiversity, it's multiplied by 10 between a level of global warming of 1.5 and 3 degrees. With increased tree mortality or wildfire, then we lose the service of vegetation and plants to store now around 30% of our carbon emissions. So it's not just a matter of ecosystems, but also the services they provide to us. Risks also affect ocean ecosystems, especially already warm water corals, but also other types of ecosystems. And the potential for fisheries catch has already been reduced in the tropics due to warming. So there are major implications for resources and food and nutriment security for people who depend on seafood for their protein and nutrient intakes. Even in Europe, we see progress in adaptation, but it is not sufficient to limit the increase in risks. And 4 main risks have been identified. Hot extremes, just like what's happening last week and this week with extreme heat very early in the season. Another key risk is the risk associated with agriculture, so shocks on crop productions associated with heat and water stress, and we've increasingly seen that in the past years. A third risk is water scarcity, as currently seen in Italy with the Po River, with increasing shortages of water that have economic damages. And the last point is the increased flooding risk, both from precipitation and river flooding, but also for the delayed sea level associated risks, increased chronic high tide flooding, increased storm surge flooding, increased coastal erosion and submersion. There are feasible adaptation options in each sector that can reduce near-term risks, in particular for food security, for integrated water management, urban transformation, and coastal risk management. I will not go in the detail of these options, but you can see in the reports their potential, conditions for feasibility, and co-benefits for other dimensions of sustainability or trade-offs that can be seen as risks of maladaptation. But there are also gaps, and there's a growing gap between adaptation needs and what is currently implemented, especially for the most vulnerable people and regions. And there are hard limits. Some nature-based solutions will face limits for a global warming level of around 1.5 degrees Celsius because of the effects of climate on ecosystems. There will be a decline in water availability from snowmelt. This concerns about 2/3 of irrigated crops and 2 billion people worldwide. And this is expected to lead to about 20% of decrease in water availability between a level of warming of 1.5 and 2 degrees. And for 2 degrees of warming, there will be hard limits for staple crops in many regions where they are currently grown. So some changes could be slowed, sea level rise, and others could be stopped, everything that directly depends on the level of warming, by limiting warming. What would it take? The first condition to limit warming is to stop the increase in cumulative CO2 emissions. We confirm a close relationship between cumulative CO2 emissions since the pre-industrial period and the level of global warming. So this is where we stand now, historical warming. It is displayed only by 2050. And you can see that limiting warming at a specific level is associated with a specific margin of action, a remaining carbon budget. The main issue is not the inertia of the climate system. It is the inertia of existing infrastructures. For instance, existing fossil fuel infrastructures, if they are used over the initially planned lifetime, they would emit around 600 billion tons CO2 more. And this is above the remaining carbon budget to limit warming close to 1.5 degrees Celsius. So how fast can we transform the infrastructures? That will be a key condition to limit global warming. Limiting global warming, it requires strong and rapid reductions in CO2 emissions. That's the major conditions. And when we reach net zero CO2 emissions, there would be almost no more warming. It also requires strong reductions in methane emissions. That can have a quick benefit within around 10 years. It can help limit peak warming, and it could also counteract the loss of the cooling effect of pollution particles resulting from decarbonization. And by doing that, we can win in two directions: less pollution particles, less ozone in the atmosphere because we have reduced the emissions of methane, and that can be a double benefit for improving air quality. So there's a major challenge for the coming years. You can see implemented policies, if there's no more action, imply an increase of greenhouse gases in the coming years. There have been pledges expressed at the COP26 associated with the Paris Agreement, but they only imply a slight decrease between now and 2030. To reconcile them with trajectories to limit global warming, it would require an abrupt acceleration of the decrease in emissions after 2030, which is not plausible if action is not prepared and implemented now. So by 2030, if we want to have a chance to limit warming close to 1.5 degrees Celsius, there would be a need to decrease global greenhouse gas emissions by around 43%, and to limit warming well below 2 degrees by around 27%. This seems huge, but the cost of action would be something between 0.05 and 0.15% of annual planetary GDP. There are options available now in every sector: energy, agriculture, food, land use, industry, cities and buildings, transport, demand and services, and low-carbon lifestyles that can at least halve global greenhouse gas emissions by 2030. I will not provide the whole list of all the feasible options. They are displayed here for each sector. The bars show the potential to reduce emissions, and the colors give an indication of the costs. This requires higher near-term investments to act on the cause of global warming. But purely on an economical perspective, the assessment shows that investing earlier provides higher long-term economic gains, even without accounting for avoided damages. And purely the gains in terms of public health by improving air quality can completely counterbalance the costs of investments to build a low-carbon economy. This also includes strategies that can support low-carbon lifestyles, including avoiding emissions from travel, having a healthy and low-carbon diet, and working to reduce emissions associated with where we live and our buildings. And many of these strategies, in fact, have health and well-being benefits, especially the types of diets we can have and more active mobility. If emissions decrease strongly, what would we see? And this is illustrated comparing low and high emissions scenarios. Air quality would improve quickly within years. It would also be the case for changes in atmospheric concentrations. It's not instantaneous, as we have seen during the COVID lockdowns. It takes several years of decreases to see long-lasting benefits. And the effects on global surface temperature, it would be discernible within around 20 years. So, to make it short, every decision matters, and every decision can take us away from or towards a climate-resilient world. Climate action has started. It's not yet at the scale needed, neither to act on the cause, greenhouse gas emissions, nor to act on the consequences, adaptation. Each shock, a pandemic, a war in Ukraine, other surprises and shocks, always place a key question. Do we want to act to build a more resilient future? Or do we maintain the business as usual that will increase risks and threats in the future? To summarize, the key findings are really clear. We have tools to act, we have options to act. The time for action is now, because the climate and related risks we experience in the future depend on our decisions. Thank you.
Valérie, thank you very much also. And I apologize to everyone. I understand now that there were some technical difficulties in the beginning and you didn't quite catch our full opening. So I'm just going to shorten this so I can hand it over to Siad in just a moment. But I just want to acknowledge Happy Stripes Day, everybody. Welcome. We are so honored at Climate Central to partner with Untitled Chapter in this media workshop where I know I personally look forward to this event every year, and I know many of you do. This is such a critical issue, as we all know, but there's also an opportunity here. And that's why we gathered this group together to help equip and enable you to be more effective climate change communicators and bring it into your work. As you know, the IPCC rolled out its full suite of working group reports. Well, in the past year, there's one more to come. And that's why it was so critical to start off with Valérie. And now we're going to hand it over to Siad, who is joining us from the UNFCCC, where he's going to give us a roadmap of what we can expect over these next coming months and prep us for COP27. Siad, welcome.
Thank you very much, Bernadette. Thank you very much, Valérie, for this very interesting presentation, as always. I'm going to give you I'm going to speak in French, because like being in France and being the French-speaking communication. So, bonjour à tous. Ce que je vais vous faire aujourd'hui,
what I'm going to do today is a presentation of where we stand regarding the intergovernmental process with everything that what is known by everyone, the COP. So I'm going to take you to Glasgow, to the COP26 last year, taking place last year, which was the most important one since the COP21 that was held in Paris, because it was the largest one ever organized on climate, the largest conference ever, which gathered the highest number of delegates ever. So it was important because it enabled something which is actually extremely important and needed. It's to keep the Paris goal of 1.5 degrees alive. And this is derived from the COP21 that was held in Paris. And it's also within the framework, the UNFCCC, that acknowledges the fact that it is needed to maintain the global warming on below 2 degrees, I should say around 1.5 degrees. And this was based on scientific research. If you can put back on the screen the presentation, please. So this was a bit of history. Maybe it was not needed, but it was to remind you of the fact that the UN Framework Convention on Climate Change was created in 1992 during the Earth Convention to fight against the desertification and drought. And also there was a convention on biodiversity. The aim was to stabilize the greenhouse gas emissions in the atmosphere in order to prevent any interference that would be dangerous, human interference on the environment. So this was the result, the outcome of the UNFCCC. And when we talk about 1.5 degree, 2.5 degrees, it's sometimes confusing. One does not necessarily see what's the difference. And what we say is that each fraction of a degree is very important. And just to provide you with a few examples of scenarios and real scenarios that were developed based on scientific research, so an increase of 1.5 degrees compared to the pre-industrial era would lead to 3% of an Arctic melting. So if we increase to 2 degrees, it would amount to 16%. And if it's 3 degrees of increase, we reach 63%. So there is a huge significance when it comes to difference and of impact. With 1.5 degrees of scenario, this is 2 months of droughts in dry regions. With 2 degrees, 4 months of dry seasons in those regions. And with 3 degrees, it's at 10 months of drought. So these realities, these facts are already present. We've experienced this throughout the world. Last year, for example, we had the floodings in Algeria, the climate disasters in the US, and also in France, in the northern part of France, in Germany, in Belgium as well. And also to provide you with an idea and examples, we estimate to $170 billion for 2021 only due or related to these climate disasters. It's not encompassing everyone and everything, just to provide you with a broad idea. So coming back to Glasgow, sorry to speed up, but coming back to Glasgow to tell you 1.5, and why do we manage to keep the 1.5 temperature goal alive. So Glasgow gathered all the countries in order to put forward indices that would be more ambitious compared to what was planned with the Paris Agreement. These are the nationally determined conditions, and each counterpart, each stakeholder has to prepare a plan in order to demonstrate how they can, on the one side, reduce their greenhouse gas emissions, and also to find mitigation measures in order to fight the climate change which is already present. We said it's ambitious because during the Paris Agreement, the idea was to review these indices every 5 years. Now we have to provide summary reports on a yearly basis. So we ask each state to be much more ambitious, but also to be transparent, and therefore to do it on a more frequent basis. There was also fundings multiplied by a factor of 2 regarding the adaptation to climate between until 2025. So this is a really important progress, because when we talk about fundings, it's always important to have something on the table. And I also wanted to show you this sentence, phase down of unabated coal power and phase out of inefficient fossil fuel subsidies. We could see it as a half full or half empty glass, because there was a discussions regarding the terminology phase down, phase out. Is it a progressive diminution or a suppression of the fossil fuels? So there were discussions around this. And we don't have much time, but I wanted to remind you of one thing, and one thing that we need to keep in mind. Jennifer Morgan, who was back then the director of Greenpeace, manager of Greenpeace, and who is now in charge of the climate change matters in the German Republic, she said, the world can change, but the signal is there. It's the very first time that we agree, and I mean by that 197 countries agreeing on the fact that we need to exit from coal power and by within the set dates. So here we see that we are confronted with a climate emergency, and that sometimes politicians do not want to see it and act accordingly. When we talk about indices, these national determined contributions, what was stressed by Valérie earlier on, what has been decided upon is not sufficient in order to be on track with the goals set by the Parisian agreements. Commitments are not met, and if the countries are implementing the plans that they have submitted regarding the summary report of 2021, the last that they sent, we would end up with a reduction of 1% of the emissions by 2030, but what we need is 45%, close to half of the emissions. Another picture, and this was also stressed by Valérie, this was the difference, the gap between so this was the United Nations program on the environment, and this is here we see the CO2 emissions and the plan of the countries in red. In green, this is what is needed to reach 2 degrees, and the one in purple is what is needed to reach 1.5 goal. So commitments were not met, and it's also the case for the largest emitters countries, emitting countries, and I'm not pointing at anyone, but facing this climate emergency, we were very close to fail, actually. And what is important is also to have everyone gathered around the table to actually take measures and to stick to them as well. So the COP26 kept the 1.5 goal alive, but unfortunately the pulse is still weak, and but there is still a lot of progress to be made. I would like to thank you for your attention. I'm sorry if I was very fast, but we're running out of time.
We are running a little behind, but we do have a couple of questions that we want to get in. This was just good stuff, so it was hard to cut off. Our first question for you, Valérie, is about the decoupling of the GDP and carbon dioxide. So what is the latest state of knowledge regarding that decoupling? Could you speak to that?
I can just mention that the Working Group 3 report mentions that in a number of countries there has been such a decoupling, and this arises from, in particular, investments in energy efficiency, as well as investments in low-carbon energy production. And in the future, what is already clear is that the investment costs to reduce strongly greenhouse gas emissions only represent a tiny amount of GDP per year, as I mentioned, between 0.05 and 0.15%. And it does not account for the benefits of avoided damages, the adaptation costs, the implications of degradation of ecosystems that would be avoided, hard to monitorize, and it does not count the health benefits of avoided pollution.
That is such important information for people to understand. We are at that point now. Another question that came in talks about climate refugees. And this, I would say, is for Valérie, but Siad, if you have anything to add to this also. Are there any graphs showing how many climate refugees there will be with the different carbon dioxide scenarios? And what is the latest research on that? Because we know it's very complicated.
So this is clearly a focus of the Working Group 2 report in several chapters, a chapter on settlements, a chapter on health and well-being. And there's an analysis of, in some cases, displacement within a given region, within a given country, as an adaptation strategy. So when people have lost their crops, basically, diversification of their livelihoods is an adaptation strategy, sometimes with the goal of coming back to the initial village or supporting family in the initial village. There are other dimensions of mobility for which climate is not the main determinant. It can be socioeconomic opportunities or other dimensions. The report also analyzes the determinants of conflict, with a conflict primarily associated with a history of conflict, prevalence of poverty and inequalities, challenges in the regulation of access to resources, and lack of education. So vice versa, you can also see that determinants of avoiding conflicts are peacemaking, taking into account climate stress. And finally, a last point is the increased number of people in humanitarian camps. And these humanitarian camps are located in regions facing extreme heat, extreme dry conditions, and they are particularly vulnerable to a changing climate.
Thank you. Siad, did you have anything to add to that?
Maybe something on a related topic. Thank you, Valérie, because you covered whatever has been, you said it all, but like, je voudrais juste donner un exemple concret qui n'est pas un scénario finalement, ce qui s'est passé.
I just wanted to say something which is not a scenario, something that took place in Madagascar last year. For the very first time, there was a crisis that was considered as the direct consequence of the climate change and migration. And this was the famine. And I know there was contested, this was linked to the draft, but the draft itself cannot be linked to the lack of water. The water cannot be impacted with human transport. But it's a very strong vulnerability to draft. It's not a direct human impact, but it's led to migrations as well. This is why I wanted to say this.
Siad, I had one final question for you before we have to, unfortunately, break, because I could have the two of you all day. But just wrapping up the recent Bonn events, what did we learn from that? And what do you want this group to know going forward from that specific event?
Écoutez, les priorités, donc vient de s'achever la conférence.
There was the climate change conference that was held in Bonn, and this is the event preparing the COP on a yearly basis. And the priority were the ones that had been set in the past, that is to say the need to adapt and to put money on adapting. And also what is important is to put the money on the table, and the commitment of $100 billion, which was confirmed once again. So the COP21, which will take place in Africa, in Sharm el-Sheikh, and these are conferences which are very interesting and that we need to keep on taking into consideration.
Okay, well, thank you, everybody, especially Valérie and Siad, for joining us for this session. We're shortening our break to about 5 to 10 minutes, so stay tuned. We'll be back up with a deep dive on strikes coming up shortly. Thank you.
Merci beaucoup.